Hello there, once again here with a PrintShift 3.0 printer, a Prusa Mini that's got a belt-based part ejection system. The biggest question I get on this machine, of course, is about the belt. This is a stock Prusa Mini. Longtime viewers will notice that this is Frankenfurter, who has the newest part ejector, the 3.0, but is still running a stock extruder. I do have a couple of videos out of replacing the stock extruder with the Bondtech or the Orbiter extruder, which is a great Prusa Mini upgrade even without the belt. This video, we're talking about belts for printing on, changing the belts, and prototyping. For PrintShift, we have the usual requirements: temperature resistance, flatness. The additional constraint we're facing is flexibility. Due to the small size of the Prusa Mini, we're dealing with a small bend radius, which necessitates a more flexible belt. So I've got four materials here. The first is the PET film, 0.005 inches. Very thin, nice and clear. It's good adhesion, inexpensive, good tension, good flexibility. It's a relatively high thermal expansion, but we solve that with the barbecue roll. That's rolling the belt before starting the print. The only problem with the PET belt is that it deforms under higher temperatures. It's just fine for PLA, but when you start printing PETG on it, you start to get deformation where the prints have been. This belt has had several hundred prints on it, and while it performed well, it's clearly not as good as it once was. The next belt is PEI film, 0.2 millimeters thick. Also good adhesion, is very low thermal expansion. It does require sanding and is quite expensive. The real kicker is that it fails catastrophically. The belt will literally split right along a horizontal line. The next belt is Kapton film. It's 0.2 millimeters thick. It's a little bit hard to come by and a little expensive, but has very good adhesion, good flexibility, and a low tendency for parts to warp on top of it. It is the primary belt that I'm using on PrintShift nowadays. And finally, a treat especial. This is the PowerBelt 3D belt. They are now selling the belts. Anyone can go and buy them. It is a fiberglass matrix, it looks like, and sort of a silicone binder. And I believe it's covered in just a PET tape or a PET film. It's a very nice belt, very interesting. I note that the CR30 as well is starting to use a fabric belt instead of, say, stainless steel, which is what its predecessor, the White Knight, uses. In a few minutes, I'll show you how to make a long belt into a continuous loop, and then we'll install this guy on our PrintShift printers. Now, older belt materials, the printer belt uses a stainless steel belt. This is covered in PET tape, good print surface. Notice the large diameter rollers, very stiff belt, but it has poor thermal qualities. It deforms a lot under the temperature. This is a printer I designed to explore larger belt-based printers. Again, using the stainless steel belt covered in PET tape. I can put a ridiculous amount of tension into this belt because this is a prototype. Not designed to fit any space, designed to have extra space so that it'll be easy to work around. I moved to the Prusa Mini because I wanted to spend more time experimenting with the belt and less time experimenting with the angled machine. So let's get back to how to make a belt. I have laser cut some of my belts, but mostly I just cut it to width first, 155 millimeters. When you order from PowerBelt 3D, you can specify that width. And then this is me cutting it to length and forming it into a continuous loop. Mark out 425 to 430 millimeters on the belt. I usually do two marks, not quite at the edges, so that when I fold it I can cut it into two pieces. Overlap the belts, matching up the length lines you made earlier, as well as the factory edge. Once it's well and truly lined up in the correct length, we're going to place it overboard and tape it down real well. It's important to keep track of the area where both belts are overlapping. Once it's taped down, we can cut through both belts at the same time. You'll have an offcut on either side, and we're going to remove those offcuts without disturbing the belt's position, and then tape the two belts together. The tape comes down to the thickness of the tape, the material it's made of, and the adhesive. To hold the belt down in the interim, I'm using painter's tape with a very weak adhesive, very thick tape. For the belt itself, I'm using very thin PET tape. It has a silicone adhesive that can handle the high temperatures of printing, and it's 0.06 millimeters thick. Now remove all the tape, clean up the mess, get rid of the overages, and if you did a decent job, you should have a nice, round, continuous loop belt ready for installation on the printer. Check the seam, make sure it's flat and smooth. Looks good. Let's get it installed on the machine. The first step is to take the steel sheet out, loosen the 3 screws holding the heated bed on in the back, and remove the 3 screws holding the heated bed on in the front. That will let you lift the heated bed, bend the rods in, and slide the old belt off and the new belt on. While I'm working on that, I'd like to talk about the project for a minute. I don't think that the question of the best belt material has been solved. Not by a long shot. That's one of my goals for the PrintShift project. Not to actually solve it myself, would be nice, but to present a useful project that will bring more people into belt printers, more people experimenting with their own belts, more people trying out different surfaces. I began this before the CR30 was around, but White Knight, the Printer Belt, and the Power Belt 3Ds are all working in this space as well, thinking about how to improve the most unique aspect of their machines, the belt. PrintShift specifically chose the Prusa Mini as a great entry-level printer, good, popular, and I designed its belt to be removable, replaceable, and even disableable. You can just take the steel bed, plop it down right on top of your belt, and print as if the belt's not there. So if you try a belt that doesn't work and you don't have time to swap it out, don't want to cut it, that's fine. Throw the flexible steel sheet on top. Looks like that went on fairly nicely. Tension it up, little test run. We're going to do a few test prints on this. I'll do a little commentary on how they're going. Just roll that off. There you go. Alright, so printing on the Power Belt 3D, it's a PET surface. It prints on beautifully. This is PLA printing now. They do recommend some glue stick if you're printing PETG so that it doesn't stick too well. No deformation that I could see under heat. No bubbles even without a barbecue roll. The belt is very nicely made. The backside being sticky is a problem with PrintShift, however. Trying to slide the belt over the steel sheet, very grippy. I don't have any tape that the belt does not want to stick to. I'm going to try and find some adhesive backed Teflon, see if I can get a smooth surface for it to slide on. The belt is also rather thick, so anything you put between it and the bed needs to be very thin. Otherwise, you're going to run out of room for the Pinda probe. So, Power Belt 3D, great job on the belt, and happy printing.